Hey guys, today we're looking at products and quotients of powers. In your textbook, it's sections 8.2 and 8.3. If you need any more examples, you'll find them there. All right, top of your note sheet, it says exponents are, and what are they? They're a mathematical function that simplifies repeated multiplication. It gives the number of times the base factor is supposed to be multiplied. For example, 4 to the 5th is the same thing as 4 times 4 times 4 times 4, or x to the third is the same thing as x times x times x. It only applies to a single factor unless there's parentheses. For example, if we have the parentheses 3m cubed, that's the same thing as 3m times 3m times 3m. Let's look at our first property here. So I have a few expressions written out on my note sheet, and then I started expanding the first two to kind of get you in the mode of doing this. And the rule of thumb when you're working with powers is just when in doubt, write it out. So if you don't remember a rule, you don't remember a property, if you just write out all of the different factors, then you can work through simplifying. So the first two here, I look at this and I have 10 times 10 times 10 times 10 times 10 times 10. Well, that's a mouthful. And I look at that and I say, well, I really have 10 to the 6th power. Then the next one, I have 3 times A times A times B times B times B times 5 times A times B times B times C. So I look at those and I look at the factors that I can multiply and create exponents from there. So I have 15, because my 3 times my 5. And then I notice I have 3 A's. Well, they're all multiplied by each other, so I have A to the third. And then I count up my B's. I have 1, 2, 3, 4, 5 B's, and they're all multiplied by each other. So I have B to the 5th. And then I have one lonely little C, and he's the only one there. So what I'd like you to do is hit pause and expand each of the next 3 and see if you can simplify them. When you're done, hit play to see if you got the right answers. All right, so check your answers here. See if you got the same thing as I did once you expanded and wrote those out and then simplified them. Now, if we look at this, we have a rule. We've got this products of powers property, and that is stated as b to the m times b to the n equals b to the m plus n. So look at one of your examples up above, like look at the first expression there, the 10 squared times 10 to the 4th. We added those exponents together to come up with our simplified expression. So the big rule to write down into your notes there in that blank column, when the powers of the same base are multiplied, the number of factors increases and the exponents are added together. And so there's that rule that we just found by working through those problems. All right, for this next set that we're going to be looking at, we're going to look at the powers of a power property. And for this one, I have some expressions here, and then I have the first few expanded. Hit pause and write these ones on your note sheet, and then hit play as soon as you are ready to expand these. All right, so in this first example, take a look at what I've done here, and I have this 5 squared to the 4th power, so we really have 5 squared 4 times because it's to the 4th power. And then if we want to even take this even further, writing it out, this is the same thing as 5 times 5, and then it's 5 times 5, 5 times 5, 5 times 5. And so we really have the same thing as we were doing in the first set of examples here, where we have this series of 5. So I count them up, and it's simplified to 5 to the 8th power. For the next one, 3m to the 1st, and then you don't have to write that first, but sometimes it's a good reminder to help you remember to count that one. And then we have this m to the 4th squared. M to the 4th squared means we have m to the 4th times m to the 4th. Then, if I think about that, it's 1m, and then 4 m's and 4 m's, so that makes a total of 9 m's. Hit pause and try the next 3 without me to see how you do. All right, so here's your answers. The first one is -7 to the 6th. Make sure you have those parentheses in there. Otherwise, the 6 is only applying to the 7 and not the negative as well. Then the next one is m to the 12th. And the last one is 1. The reason why it's 1 is any number to the 0th power, or the power of 0, is really just 1. And so we really have just 1 times 1, which equals 1. So looking at this one, the powers of a power property, the rule that we're going to be using for this is this. Times n equals b m n. So we're going to multiply those two powers together. So jot this rule in that last column there. When powers of a power are calculated, exponents are multiplied. See how I snuck that little d in there? And then there's the rule. Our last set here, for this one we're looking at the quotient of powers property, and for this one I have these examples, and then I have the first two expanded. If you notice, I have 10 to the 6th over 10 to the 3rd, and for this one, the powers that are same factors, they cancel each other out. So 10 and 10, 10 and 10, 10 and 10, so what we're left out with is 10 to the 3rd. For the next one, I can simplify the factors the same way. So B and B go away, this B and this B go away, A and one of the A's go away, and then for the 5 and the 15, I can look at that as a fraction of 15 divided by 5, which is 3. So then I have 3, and then I have 1 A left over, and I have 3 of the B's left over. So that's what that would look like as a simplified form. So hit pause, try the last 3 to see how they go. All right, here's the answers for those last 3 examples here. So after you expanded them out, you'd end up with negative 4p cubed for the first one there, and then 2m squared n squared, and then finally this third one I wanted to talk through. So if I expanded it out, I got this right here, and the only thing that actually canceled itself out was this x. So we ended up with this 7wx squared over 2. And then this negative right there should pop to the top because that's how we write our negative fractions. So then here's the rule or the property that we use for this, the quotient of powers property. And you just simply subtract the exponents, m minus n. And here's the property rewritten a little bit more clearly. When powers with the same base are divided, so that's a really important part, the same base are divided, the factors simplify and the exponents are subtracted. So there's the property that we're going to follow. Finally, I just had to toss in this dorky little exponents joke. So exponents are number 3,924 to the power of 0. If you don't get it, ask someone nearby and they can explain it to you.